We're going to talk a little bit about subscriber services, what's happening in the industry, the big leap that we're taking, or quantum leap, and really what Cisco's doing in correlation with that, mirroring that, and really what we're doing to lead this going forward. So, without further ado, let's jump right in. Cloud native BNG. We're going to talk a little bit about what that is, why we're doing it, what problems we're solving. Not too long. We're going to just spend a little bit of time, and then we're going to get right into the architecture. We're going to talk about what makes up this solution, what are the components of this, and then really get into the nirvana of this. Where are we going with this? What is this? Where is this taking this this general movement, and where we're going from a convergence standpoint? So that's the agenda for this session. So let's jump into the overview. Like any technical problem or technical innovation, we really need to be thinking about what are we really trying to solve here. We need to really kind of get into that and figure out what is going on today and why are we going down this path. So we have a smattering of different things that a lot of operators are experiencing on a day-to-day basis and how they build out their networks. And specifically, we're talking about the context of fixed line networks and subscriber services. I'm not going to go through all of these, but if you boil this down, there's a couple of key things. One thing is the way that we've built our fixed wireline networks and where we terminate subscribers is really sort of incongruent with the efficiencies and the service models that we really want to see and what are really the end customers are demanding. So things like having the proper association of the services that they're trying to access and having them as close to the subscriber as possible. That's something that we're really trying to go after right now. A lot of times that's sitting far away from the subscriber, and you end up experiencing long latency times. This also leads to high density subscriber termination, which is a large failure domain. The qualification of how we do and hand out new features and new services for those subscribers, that's quite laborious, often requires full system upgrades. There's a lot of limitations in the way we've built things really towards how things were really done before with the new connectivity models, the new services that are coming out for subscribers. This really demands a rethinking of how we're doing things. So there's many more challenges that our operator base is really facing, but this really, the solution that we're going after is really attempting to solve for a lot of these. So let's talk about the shifts that we're really experiencing and what we're seeing at an industry level, at a standards body level, and ultimately now what we're delivering on. So first of all, the shift on the control plane side, we're seeing cloud is prevalent. It's pervasive in all areas of the network and both public, private, et cetera. The ability to take the control plane, something that really is historically sat on platform, co-resident on a BNG, and be able to move that to the cloud and allow that to scale appropriately. This is a huge movement that we're seeing here that really provides a lot of new things that we can talk about here in a second. So that's one thing that we're seeing. Second is we're seeing the user plane of where we actually terminate a subscriber and allow them to go where they really want to go. We're seeing this pushed further and further out in the edge. So out into the metro, out into the aggregation or pre-aggregation space. And there's really a couple of key reasons for that. We'll get into that too. And then the third thing is operators really would like to see the ability to offer a unified policy and have subscribers treated equitably regardless of how they're actually getting access to the network. So whether it's mobile, fixed, cable, Wi-Fi, they want these subscribers to be treated the same way. So these are some of the things we're seeing from a shift perspective. So what do we get out of that? So first of all, by moving that user plane further out in the network, we're going to see a reduction in transport costs. We're going to be able to offload subscriber traffic quite quickly. We're going to be able to attach those customers to low latency services because we're putting those services further out in the network. We're also optimizing our OSS/BSS integration points because when we move our control plane into the cloud, the presumption is that we're going to be able to horizontally scale that to the point where we're not scaling on a per BNG or per user plane basis. We're actually scaling on a per network basis. That reduces the amount of integration points and really decouples that from the actual physical user plane. And then finally, if we're able to get to this convergence that we're going to talk about, we're able to deliver a single policy regardless of how that subscriber is getting access to the network. So operators in this environment are going to see reductions in operational costs and in capital costs because they're able to right size each part of the solution based on their subscriber base, the services they're going after, and what services they're offering. So how do we get to this? Our solution, we've got 4 major components of this. First of all, we need to move our control plane into the cloud. We've done this. This allows us to take advantages of all the goodness that cloud gives us, provides inherent redundancy, it provides the ability to scale horizontally, and it allows us to rapidly deploy new additions to our feature set and to our capabilities without having to worry about impact within the underlying network directly. We're able to upgrade that control plane seamlessly. Second, we're able to really go after all the user plane options. We're not pigeonholed into specific user planes. We're able to look at all the different user planes that are out there and build on those and right size those based on whatever the operator is looking for. Third, the converged subscriber management infrastructure. If we want to get to convergence, we need a common infrastructure to build on, and be able to reuse some of those common building blocks that we see within subscriber services. So we've already implemented this. This is in place. We're going and building and further on top of that. And then finally, Phil, when we talk about any new service, we need to have it automated. We need to be able to see what's going on within the network. We need telemetry coming out of there proactively so we can see the health of the service, the health of the overall deployment, all the different pieces that go into that. And this allows for, obviously, the ability to manage this network much better, but it also allows us to integrate much, much easier as well. So let's talk about the architecture. I didn't want to spend too much time talking about the basics here of why we're doing things. Hopefully people are paying attention and know that. But the architecture is really how we're realizing this. So this is a simplified view. We're going to get into a little bit more detail as we go forward. But at the top, these are the traditional systems that you see within a residential wireline deployment. You'll see AAA, you'll see policy, our billing systems. These all need to exist regardless of what we do here. And those are the things when we talk about the integration, this is what we're integrating to. Underneath that is our control plane. In days of past, that control plane sits co-resident with those user planes that you see on the bottom, all one system. What we're doing now is we've moved that control plane into the cloud, leveraging, on top of a Kubernetes cluster. We have a couple of options that we're deploying on top of either CVIM or CNDP. These are Cisco standardized infrastructures. And in that control plane, we have 2 kind of buckets of CNFs that sit there. So one is what we call SMI CNFs. And I just touched briefly on our subscriber management infrastructure, or SMI. That CNF are things that we can build that are common, regardless of whether you're coming in residential wireline BNG, whether they're coming in cable, mobility. These are things that everybody uses. And then there's some things on the BNG side that are specific to BNG. We can't, build those common across everybody. So we have pieces of those as well. And so those sit in the control plane. And then there's a set of standardized interfaces that connect between that control plane and the user plane. These are being defined within the context of the Broadband Forum, which we participate avidly in. And we've got options here on the user plane side. So we have our existing BNG. These are already enabled for user plane. So we're leveraging those out of the gate. We're already doing that today. We're looking at new options. So there's the ability to look at different options based on the place of the network and implement user planes there. And then finally, we've been in this long-standing standoff of when does it really make sense to virtualize some of these functions, especially things that are user plane or data plane focused in the virtual environment, in an x86 environment. The advancements there are really kind of paying off and taking us down the path where this is really starting to make sense. So we've taken steps here and we'll continue to progress on this, where you can deliver a virtual BNG in an x86 environment, have that connect up to the control plane. So regardless of your deployment model, you have an option, regardless of the user plane.
I've got
this
a question
is a high-level
Andy.
architecture. Sure, yeah.
So in looking at this architecture, just to orient myself, are you saying the user plane is the data plane? That's for those VNF functions, that's the data plane, or are we still talking control plane there?
Nope, control plane is all in that middle
That's your
So
middle
those
one.
virtual,
Got it.
yeah, yeah.
So in scope of that, where does quality of experience and shaping come in? I spent a lot of time building out rural ISPs, metro ISPs across a lot of different vendors, and that's something that we almost every single day, I think, we're slotting in QoE L2 shaping engines with some kind of an L7 control hierarchy to look at that. Is it YouTube? Is it Netflix? Where does that kind of an element fit in here? Is that native to Cisco's solution, or is that something that you would integrate from another vendor that plays in the QoE space?
I mean, if you're talking traditional wireline QoS models, you're going to see those implemented in the user plane. But traditional user planes today typically don't go beyond L3, L4. So if
Right.
you go into L7, so to your point, if you're going at the application level, we would have to export data to something to munch through that. We can still drive policy back down in implementation for how you want to treat that within the user plane. But usually you're going to need something to look that much deeper that's outside of the existing user planes that we have today.
Right. So there's a whole market for QoE of vendors that,
Yeah.
that tackle that space. How would I bring one of those into this architecture?
I mean, you would use standard programmable interfaces like we would have into traditional BNG space. And so they would you would have, ship out NetFlow data or whatever, however they'd like to consume that from the user plane, have that be consumed off box, plug into the user plane. There can be coordination back through the control plane as well, if you want to update policies and drive that through there. But the actual, it'd be connected. It's not really on this picture,
Got it. Okay.
All right. Let me just at least set the table on the convergence side of things, and then we'll let Rana take over and take us through one level deeper. If you look on the left, this is kind of what really today's networks sort of look like, and if you superimpose Cisco products on top of this, we have Ultra Cloud Core and CNBR, and these sit on top of cloud native infrastructure. They're a little bit siloed in that the actual functions themselves are specific to them in terms of mobility and cable. And BNG is really, in the past, prior to our launch here, is really sitting completely independent of this. What we've done is we've taken this step into phase one. We have a converged SDN infrastructure that really is, designed to transport whatever type of service you'd like to basically transport from point A to point B. This is, built on top of our SR, EVPN infrastructure. It's programmable, et cetera, et cetera. So this infrastructure is in place. On top of that, we have our cloud native infrastructure. And now we built CNBNG to sit there. This is our control plane. The Ultra Cloud Core and CNBR persist. And where we're going to go is phase two, where we have this converged control plane. We're doing common policy and common implementation of that control plane on top of this cloud native infrastructure, and then have that unified policy sit on top so they can drive and see all of these different access types, and really leverage what we've been doing from a converged SDN infrastructure at the same time. So this is high level. We're going to get into the more detailed view as we go forward. So with that, I'm going to hand off to Rana and let her take us through the architecture one layer deeper.
Great. So I think if we, take a deeper look and basically follow through what Andy went through in the beginning. So we obviously have a control plane that's fully cloud native, and we basically have a variety of user planes, both physical or router MPU based and also virtual. And if we take a look at the architecture, we have a fully cloud native control plane that actually has a set of microservices to cater for the different functions that we need. And this is actually built on full alignment with a clean sheet architecture that actually aligns to not just the BNG world, but also for 5G and cable, so that eventually we can easily move towards wireless and wireline convergence. So if we take a look at the components here, we basically have a unified operations center, which allows us to really manage that cloud native infrastructure, do all the lifecycle management, the monitoring, the configuration management in a seamless manner. We've got a common data layer, which is a Cisco database where we can store all the session information within that unified place. We've got policy interfaces, and we've actually aligned those across the different stacks. So not just supporting diameter and radius like we do in traditional BNG, but also introducing support of HTTP2, which is actually the interface that is used in the 5G world to interface with the policy layer. So with that, you actually can then move towards a unified policy layer that can work across BNG, but also your 5G core. And then we've got a lot of common protocols, which again can be leveraged across the stack, like DHCP and others. And we've got an application infrastructure that really allows us to drive that connectivity and the load balancing between those different microservices in a very efficient manner. And anything that you see here in blue is actually common across the stacks and the control plane, whether it's on BNG or the 5G core. Then we've got the BNG kind of function, which is really terminating those and catering for those PPPoE or IPoE subscribers, which is obviously a BNG specific function. And then the control plane to user plane connection, like Andy mentioned, so this is fully aligned to standards, aligned to both Broadband Forum in WT459, which really defines the COPS architecture or the control and user plane separation for BNG, but also in alignment with 3GPP so that we have a unified set of protocols across the mobility side as well. And as you can see here, we can have a single control plane that can manage different types of user planes where we have a variety of user planes to cater for different deployment models. So, we can have customers that actually want to use existing ASR 9K install base based on Tomahawk, for example, and actually be able to convert those as user planes within a CNBNG architecture to give them that investment protection. And other customers that would want to maybe expand to Lightspeed Plus user planes and maybe also virtual user planes. As they're building their mobile edge compute data centers, they can actually host their virtual distributed user plane connecting to that same control plane as well. We're also working on leaner user planes within the pre-aggregation aggregation layer that really allow us, as Andy mentioned, to offload the traffic earlier on to get those savings, but also allow us to be able to leverage the same routers that you would anyways use for pre-aggregation and aggregation and drive convergence there. And as a result of that, you can actually totally eliminate dedicated BNG nodes that only did BNG before. And with that, you get significant savings as well.
So I have a question around this architecture. As I look at deploying BNGs, I'm in the middle of a build of an ISP right now where we're figuring out where we want our BNG redundancy to be at the COs that we're building out. So traditionally, we'll build the primary BNGs to be active in one CO or data center, and then a redundant DC or data center within the same region. But there's some manual work in going and figuring out those pairings. Does this orchestration make it easier to build BNG high availability, and how do you manage that in this framework? How is that working? Because that's something that could be a significant challenge in planning the last mile services in a region.
Yeah, definitely. And we've got actually redundancy at multiple levels, right? So if we look at the user plane side, we have what we call the geo redundancy, where we basically can have across two different user planes. They're fully geo redundant. They only need to be connected via layer 3. And basically you can kind of fail over your sessions from one BNG user plane to the other. We obviously have redundancy as well within the control plane. So there is redundancy at a cluster level. So within a Kubernetes cluster, you can obviously do redundancy by spinning up microservices and doing the failover there. And we can do that also across clusters. So there's definitely redundancy at every layer of that architecture, and we get that superior performance.
Gotcha. So I could build clusters within a region and then failover between clusters in maybe different regions if I wanted to build that kind of an architecture.
Exactly, right? So, as long as you've got that layer 3 connectivity, you can do that. And they're like in sync with each other through that layer 3 connectivity.
Gotcha.
So along these same lines, like I've spent a lot of time in the decoupled control plane space, like running that in production. So I have all the burn marks from the typical things that break. Can you speak to what happens if connectivity to the cloud control plane goes away? Does it fail open? Does it fail closed? What are the caveats?
Yeah, so basically, if you kind of take a look at this, all the rules are programmed on the user plane as well, right? So if you lose connectivity to the control plane, the user planes can actually operate, seamlessly, right? There are some things that obviously you need to cater for. For example, if you've got your DHCP, a centralized location, and then over time you kind of time out on your DHCP lease. That's obviously something that you need to cater for, but I think that's independent of control plane and user plane separation. You would still have that anyways in a traditional like BNG network, if you have a separate DHCP server.
Yeah,
But
for sure,
yeah,
sure.
yeah,
Okay, that's good to know. I like the way you've done that. Thank you.
perfect. So, like Andy mentioned, we've kind of built that over a subscriber management infrastructure that is actually common. And it's really meant to really simplify and fully automate this infrastructure to make it easier for customers to basically adopt the move to cloud native. So we've got, a Kubernetes cluster manager that really allows us to do, all the provisioning, deployment of that Kubernetes cluster and do the lifecycle management. We've got an operations center, which really is around, how do we, develop all the right automation APIs that we can really do the management via netconf, REST, but also leveraging, CLI-based interfaces and YANG models. We've got also what we call the common execution environment. And the function of this is really to get that streaming, telemetry data, all the OAM data, so that you can do all the alarming, logging, and basically be able to trace, across that infrastructure. There's also the intelligent service mesh. The target really here is to have that service mesh to allow you to connect all your microservices in a seamless manner, allow you to do all the traffic steering, the load balancing, and really take care of that automatically in the infrastructure. And then the common data layer that we spoke about, and that's really around having that common database. You can store your sessions there, and have that geo-redundancy in terms of your session storage and information, and doing that in a very low latency manner with high performance. And if we take a look at like one of the main benefits like of why like moving to cloud native BNG, the fact that you now have a centralized control plane that can basically manage many user planes, and you can actually distribute user planes as much as you want into the network, because you now have a single entity that actually interfaces and does integration with your OSS BSS layer. And you can distribute to many user planes that can, as we said, offload the traffic earlier on to save on your transport costs without really increasing that operational burden with a centralized control plane. We've also been focusing on, not just leveraging all the inbuilt characteristics that we have with like Grafana dashboards, like fully open source, where we can show all that data centralized, but we've also complemented that with our automation stack to do full fault and performance management, so you can have a single pane of glass across all the infrastructure. So your user plane, your control plane, the virtual infrastructure that you're running your control plane on, all managed within that single pane of glass, and you get that network-wide view for all your subscribers. And you can integrate with only one entity, which is that unified centralized entity, instead of having to integrate with the hundreds of user planes that you're building into the network. Now, when we started on this journey, and that was several years back, one of the major constructs and the key design constructs that we had was around wireline and wireless convergence. And we wanted to start with a clean sheet architecture as we move towards cloud native. And the idea was not to just leverage code that we had, which we had for many years, running on ASR 9K, for example, and taking that, putting it in a VM, and running it virtual and saying, we've got a virtual control plane. But we actually focused on looking at the architecture transitions years ahead, and making sure that everything that we're building it based on a clean sheet architecture with cloud native constructs, but also keeping in mind that we need to have commonality across BNG and the mobile side with the packet core and also cable. Because in reality, if you actually look at those three stacks, they're doing very similar things, right? They're doing subscriber management, they're terminating a subscriber, they're applying a policy, they connect to your billing systems and so on, so you can do charging. So it's actually the same function, but obviously they're separated because of the different technologies that they're access technologies that are connected to those. So if we take a look at how networks are today, some operators are running fully siloed networks. So not just from the subscriber management stack of cable, BNG, and packet core, but also on the policy layer, you have separate policy interfaces that then tie into your IT systems. And on the transport layer as well, the IP layer, they have separate networks to actually backhaul the traffic for each one of those from each one of those access technologies. Now, the first phase of that convergence is really going towards converging all the transport networks that you have that can be separate over what we call the Converged Transport Network, leveraging all the capabilities with SR and EVPN, where you can adapt in real time to the different service requirements, and also then converge the cloud native infrastructure, right? So you're going to move anyways to a COPS architecture, cloud native infrastructure. You can build that over the subscriber management infrastructure that we mentioned with all the components and microservices as common as possible, while obviously still maintaining a separate termination for BNG, then mobile, and cable. But you can also unify your policy systems. As I mentioned earlier, we have common interfaces across the stacks. Now, the final stage of convergence would really be that, moving even a step further and having your 5G core be the sole entity that's actually managing all your subscribers, no matter what access technology that they're actually coming in from. And with that, you get the full convergence on the transport layer, on the cloud native infrastructure layer, and on the subscriber management stack, and on your policy layer as well. And if we take a look at that architecture in a bit more detail, everything that you see here between that's actually blue or gray is actually common across the stacks. The subscriber microservices infrastructure that we mentioned, how you manage that infra, how you do all the logging, telemetry, operations, and lifecycle management, it's fully common. And all the common microservices, like where you store the data of the sessions in that common data layer, how you do the common protocols, how you have a unified policy interface northbound, and basically all the application infrastructure. And even the protocols between the user plane and the control plane, again, moving to a standards-based approach to evolve towards convergence as being defined in 3GPP and in broadband form. And if we take a look at how would that actually look like from a network perspective, you would have that single converged SDN transport network where you basically have your X haul, you've got your front haul, mid haul, back haul, basically all of that converged, and you're basically connecting all your access technologies across that same infrastructure, running over that SR and EVPN network with all the timing and security capabilities as well. But then you have separate access tunnels, right? So if you were talking about wireline coming through BNG, you're going to have your tunnels that are IPOE or PPPoE. If you're coming through the mobility side, it will be a GTP tunnel. And then eventually you get towards a converged user plane and converged control plane that can actually terminate the subscribers there across those stacks. And you have a unified framework, a unified automation stack, and unified northbound integration with your OSS BSS systems.
So I've got a question for you. In looking at the architecture that you're laying out, and one of the things that you're doing here and simplifying the ability of these different access technologies within the carrier network to all leverage a common infrastructure, one of the trends that we're seeing, at least in the North American market, and I think it's happening some in the European market, largely driven by things like Starlink, is when you're looking at fixed wireless broadband, a lot of the large carriers are starting to use their 5G and LTE assets to deliver fixed wireless broadband, which has traditionally been isolated, siloed RAN networks that were, they don't join the MPLS network until you get to a common point. And what you're suggesting here, where everything is on more of a converged platform, how much of a driver has that been that the carriers are now starting to use their LTE and 5G assets to compete in the fixed wireless broadband space for this kind of an architecture?
100%, and that's actually a perfect segue for the next slide. While you shifted that, Andy. So basically, if you actually take a look, exactly that's what's happening, right? So basically, we're seeing operators that also want to differentiate their services. So in cases in countries where maybe you have a single last mile access, provided by a single operator, and providing that as a wholesale service to other operators, they're actually looking at how can we differentiate our service and make sure that we have two links into our customer base where we've got 5G uplink, we've got a wireline uplink, and then we're monitoring the SLAs, and we can basically shift from one access medium to the other to basically give a superior SLA and a superior service. And to your point as well, in cases where some operators don't even have that wireline infrastructure backbone, and they want to offer a service, they can go to fixed wireless access and basically provide their 5G based CPEs where you can kind of offer that service towards residential customers. So definitely that's been a driver. And to really enable our customers to go and offer those differentiated services, we need to have unification of the stack, unification of the system, so that it becomes much easier to operate and to manage. And if you actually take a look here, this is also being defined in standards, and this is done collectively with 3GPP and Broadband Forum, and Cisco takes part in both of those forums. And if you take a look here, the whole premise is, eventually that 5G converged core would manage all the subscribers, and then we would basically have coming in from different access mediums. So for coming in through wireline, instead of having all those wireline protocols like PPPoE and IPoE being supported on the 5G core, which wouldn't be very productive, there's a function called the access gateway function that is really meant to do that translation. So you're meant to basically terminate there your PPPoE and IPoE tunnels, and that access gateway function will kind of initiate GTP back into the 5G core, so that the 5G core understands that as if it's coming from a wireless access, right? So everything that you see in blue, which is related to wireline, which is the AGF function, or basically the residential gateway, that's being defined in Broadband Forum. Everything that you see in red, which is related to the 5G core and all the wireless interfaces as well, that's being defined in 3GPP with full alignment to get towards that convergence.
Gotcha. That was a great explanation. Thank you. And one follow-up question to that is, are you, with this architecture, has it been deployed in production with CBRS yet here in North America?
Yeah, so the evolution towards convergence is actually still evolving in standards. So that's something that is being evolved, and the standards are defining that, and eventually basically we build the right architecture in our products to support that in the future. Now, if you're just talking about pure cable, CBR8 and how we do this in cable domain, of course we have deployments there with cable access.
Gotcha. Okay.
Perfect. So to summarize on this session, we spoke about a lot of things. To kind of look at really what are the benefits of moving towards cloud native BNG, and what are the Cisco benefits of such an architecture. One of the main benefits we focused on is really building a control plane that is fully cloud native, fully automated, that can really scale up and scale down based on really the requirements that are coming from the network, right? If you take a look at the components themselves, we're separating the processing from the state so that we've got separate microservices. And basically, if you want to scale one dimension, you don't need to go and replicate a monolithic software stack and consume a lot of resources onto your servers, which is expensive. But you can do it in a cloud native manner where you can, for example, if you want to increase the number of subscribers, you can do that by increasing the memory of your database while keeping all the number of CPU cores that you're running constant. If you want to increase your connections per second, which is more a processing function, you can just increase your CPU cores, but by keeping all your memory and storage constant, right? So you can really get that flexibility of scaling out in a cloud native manner. One of the other main advantages that Cisco has been focusing on is really enabling disruption in the economics of how we do BNG, having more distributed BNG user planes that are lean. They're the same aggregation platform so that we can eliminate dedicated BNG layers in the network and drive cost savings there, and allow the traffic to be offloaded earlier on. We have a lot of focus on the overall converged SDN transport architecture, and it's really around how do we simplify the access, how do we ensure that redundancy is done in an active manner and very fast convergence, adding all the SR and SRv6 capabilities of service chaining, so we have a very easy to manage infrastructure. Everything that we do here has full telemetry and programmability with a large collection of KPIs that can be monitored, giving full visibility across your subscribers. the architecture, as we mentioned, is fully ready for wireless and wireline convergence. Some people call that fixed mobile convergence, to really enable our customers to get those TCO savings and drive those new service models and SLAs. Obviously, if you look at the end-to-end ecosystem to make this successful, you basically need not just the BNG function, you obviously need the stacks like cable and mobility, which Cisco also offers. You need a cloud-native infrastructure with all the servers and the software-defined fabric and the automation stack, which again, this is end-to-end Cisco capabilities, and we can really provide a turnkey solution for each one of those components.
I can't ask any technical questions on this side of the world. I'll leave those to Nick and Kevin. But I play on the enterprise side of the world, and you've talked a lot about automation here. Network automation on the enterprise side of the world uses, sources of truth and version controlling and things like that. Do those same concepts apply to automating this gear? And if so, is it the same tools like Git and other things like that? Like, what does automating this type of network look like compared to automating an enterprise network?
Yeah, and definitely there are similar constructs. So like you said, how we look at version control and rollbacks and so on. If you look at components like the NSO, or the Network Services Orchestrator, which is actually a common component being used in enterprise, being used in here for service provider networks, it has those constructs, right? So you have the right version controlling. You go do orchestration over the network in case it doesn't go through. You can roll back. Based on that mechanism, which is exactly the same, right? So it's common constructs. We leverage common components as well to allow us to kind of unify the automation stack there.